Welcome back, everybody. I'm going to give you a quick rundown of where I am so far with the plasma thruster. Well, this is where I had designed before, and this is what was the original concept. It was supposed to have these called spark gap train that allows the ions to flow around the chamber so as to be ejected by the ejector coil here. The confinement coils here on the side were now supposed to hold the plasma in place so that it doesn't veer off from outside the chambers. But when I actually built and tested this, I fell into a problem where the spark was arcing over to a shorter distance and not following the circuit parameters. That's what I had a problem with. And the biggest problem was also manufacturing this. I had to manufacture this by hand. These are all brass pins that I took from a long brass wire and individually put in as I cut them along the way. These are over 500 pins altogether. That was a lot of work just to 5 hours really to put all these pins. So initially, after testing this, I found that this method of approach, at least to the manufacturing method that I'm using, would not work. And also using the help of ChatGPT, I figured that initially I had assumed that the only voltage that needs to be jumped here will have to be the voltage potential between these two pins, and that would be the same all over. But apparently you have to add all the air gap voltages since there are air gaps in series, and that meant that I had to have over 100,000 volts. That was not within my capabilities. So I changed the plasma thruster from that design now to a triangular design. Now, it's no coincidence that this is also the same way that Tony Stark went with his repulsor design. He started off with his being a circle like mine and ended up with a triangle when he tried to make it better. This is just what I ended up with when I was doing the process, and the process was now converting those brass pins into PCBs. As you can see here, now we have this instead of the brass pins working. Now this is what is going to be facing the inside of the chamber to now create the plasma ejection. So now this is where I've reached on this part, and I've designed this to make it like a tetrode. Let's look at what that PCB looks like. If we now look at the PCB in the design window, just give it a moment. My computer isn't that doesn't have a very fast graphics card. Now, this is how the PCB looks like in the design software. As you can see, everything in red is the top copper layer, and everything in blue is the bottom. The bottom copper layer. Now, as you can see, this built it as a tetrode design, whereas the positive voltages or the negative voltages are separated by these two gates here. Each gate controlling one voltage, this one controlling this voltage here. And you can see the voltages, the gate voltages are all linked together through a two-layer PCB. The bottom blue wire connects the top gates together, and then that allows them to it allows the current to flow through. So actually not even a current, it's just a voltage potential. So it creates a voltage potential between this gate and this emitter, and also creates a voltage potential between this gate and this emitter. So this is essentially, in a way, kind of like works the same way as particle accelerators, but only a 1-unit particle accelerator. It accelerates particles from this side to this side, and it uses these gate voltages to decide when and how to accelerate those particles and the voltages. So then, after building that, I did what was necessary and went over to let's see if they're there. Oh yes, went over to JLC PCB, made my order. It was already done, and let's see, there are the two components: the inner tetrode and the outer tetrode, and they're already on their way here. So finally, I was able to get this done and completed. With this, on its arrival, we can now go back here and now focus on the body part. The body is almost complete. I just need to now put in the actual coils. As it is right now, it's bareback. Again, give it a minute. My graphics card takes a bit of while. So once this is done, I will now just take these boards and then place them in the slots in here, in between these channels, like on this face and on this face here. And then inside the faces, I'm going to put the ejector coil on the bottom face, and the confinement coils inside these grooves here. And then after that, I will have my plasma thruster fully complete. The new version is how it looks like. So there's where we are, and now we had to include a few other structures. Now, on the plasma thruster as well, we have one more thing that makes it quite unique. On the back side, rather than just wasting the two layer options, I decided to also include this trace line behind here. Right now as it is, it's connected on both ends because it's supposed to be a parallel connection. When you do it as a parallel connection, it will act like a plasma thruster. But when you cut, if you were to take a knife and then score and cut this portion off so that it's no longer complete and the current can flow now from that side to this side, it turns now this from a plasma thruster to a linear path accelerator. So you can accelerate what do you call it, small amount of particles using now this one. This is a very compact form of a plasma accelerator. I mean, a charged plasma accelerator. People like CERN would have really enjoyed this one if they could have had access to it. Because now look at this. This is no more than 197 millimeters long, and it can accelerate charged particles in that direction, in either in the length direction. When you cut this section off, just one of these, either this side or that side, whichever. You can cut whichever side you want and then use those two as terminals. Right now the terminals is that side and that side. But to make it into a particle accelerator, you just score one of these sides off and then you connect it in the particle acceleration what do you call it, configuration. But I haven't shown that yet. So once these come is now when we now put them together to create our final plasma thruster, which will now look something like this from the top view. I need to now put these inside there. But yeah, that's where we are now. So hopefully let's get these to where I am. They should be here any day soon, and then we can finally progress and make this thing. The future is here. There's no need for us to be held back by, you know, technologies of the old. Right now we should be focusing on things that are in the next future. We should now be going forward, and this is the first step towards that.